Hi everyone. So for a while now we've been talking about systems of linear equations and graphing them and their relevance, but today we're going to be talking about something a little bit different. We're going to be talking about linear inequalities. So let's have a little refresher first on inequalities. An inequality looks a lot like an equation, but instead of an equal sign, we have a less than, greater than, less than or equal to, or greater than or equal to sign. And for inequalities, much like equations, there are many ordered pairs that make them true. So, in the case of x plus 3y is less than 6, 0, 1 makes it true, 1, 0 makes it true, and when I say makes it true, when I plug in the x value of my coordinate into my equation and my y value into my equation, this holds true. So the left side is indeed less than 6. So all of these points work, along with thousands more. So they're all true. So how do we express the solution set of a linear inequality? Well, we show the solution set on a graph by shading. And we'll go over this in a bit. I know some of us have seen it before. We show our solutions by shading, and there are a few ways to graph linear inequalities based on the information that you're given. If we're given an equation, say in standard form, there are two things we can do. We can either pick points on our graph, pick points above and below our boundary line. We can pick points and plug them in to see if they make our inequality true. We can also convert our standard form equation or inequality into slope-intercept form and determine the shaded part based on our variable and whether y is greater than or less than the rest of my inequality. So we can convert to slope-intercept form. All right, let's do some examples with these. All right, so in these examples, we're going to be looking at systems of linear inequalities. So that means, just like systems of equations, we're going to have two inequalities, and we're going to have to find solutions that work for both inequalities. Now, unlike systems of linear equations, we're going to have more than one solution when we're dealing with inequalities. So let's graph these two inequalities and see what happens. So this first one I'm going to do in blue, and this inequality here is already in slope-intercept form. So I can identify my slope. My slope is going to be 1/2, and my y-intercept is 1. So I can find those on my graph and graph them. And before I do that, I want to point out something. So we can have greater than or less than signs, and we also have greater than or equal to or less than or equal to signs. Now this matters when I'm graphing because my boundary, that line that I'm going to draw, is going to be dotted, meaning those solutions do not work for my equation, or solid for inequalities with an equal sign. I'll show you what that means. So let's graph this. So my y-intercept is going to be 1, and because my slope is 1/2, I will rise 1, go over 2, rise 1, go over 2, so on. And the more points I graph, the more accurate my graph will be. So there is the line that I will graph, but I don't have that equal sign, so I have to make this dotted. I have to show that all of these points that fall on this line here don't actually fit or don't make my inequality true. But what points here do make my inequality true? Well, that's where we have to look at this y is less than. So if y is less than everything that I've graphed here, I can look at all of the points from this point downwards on my y-axis, and all of these points will make my inequality true. So all of those points in the blue region make my inequality true. All right, so let's graph this second inequality here. So the second inequality is in standard form. So I'm going to use this. I'm going to use our first approach that we talked about for graphing inequalities. I'm going to pick points to determine where I'm going to shade my graph. But first, I need to graph this boundary line. So it's in standard form. Let's use the approach where we solve for the x and y intercepts this time. So I have, if I'm going to solve for my x-intercept, I'm going to have 5x plus 2, and then I'm going to sub in 0 for y is greater than or equal to 10. And then this just goes away, 2 times 0. and I get 5x is greater than or equal to 10. And then I get, when I divide by 5, I get x is greater than or equal to 2. So my x-intercept is going to be 2. So I can find that on my graph here. Graph this one in red. And if I solve for my y-intercept, I'm not going to go through the steps, but my y-intercept, when I plug in 0 for x, is going to be 5. So y will be 5. So I'll get y is greater than or equal to 5. So I find that on my graph, or 5. And then I can connect my 2 points to make my line. And now we have to determine whether our boundary line is dotted or solid. And in fact, it is solid because I have that equal sign there. So now I have to determine which way I'm going to shade. Well, I have 2 options. I can shade to the left of this line or to the right. So let's pick points on either side and see if they make this inequality true. So let's say 0, 0. That's an easy one. So let's plug in 0, 0 for this inequality and see if it makes it true. So I'm going to plug in 0 for x, 5 times 0, plus 2 times 0 is greater than or equal to 10. Let's see if this makes it true. Well, 5 times 0 is 0, 2 times 0 is 0, so 0 plus 0 is just 0. So I have 0 on this side is greater than or equal to 10. But you and I know 0 is not greater than or equal to 10. So everything on the left side, including that point 0, 0, does not make my inequality true. So that means I need to shade everything to the right. And if you want to be extra certain that what you're doing is right and you didn't make an algebraic error, you can check a point on this side or another point on the left side and make sure that it all adds up. So I'm going to shade everything over here. And now I have a space on my graph where these 2 shaded portions overlap. And that is the solution set to my system of inequalities. So everything where these 2 overlap, so in this area right here, all of that are points that make both of these inequalities true. So that is my solution set for my system. All right, let's try another example. All right, example number 2. So for this one, we have 2 inequalities again. We're going to graph them. But this first one, I'm going to do something different. I'm not going to find my x and y intercepts and graph those. Instead, I'm going to use that second approach that we talked about earlier, where we convert to slope-intercept form and then graph from there. So let's do that first. I'm going to graph this one in blue. Now, if I take this equation, this inequality, and I say 3x plus 4y is less than or equal to 12, well, how can I convert this into slope-intercept form? If I convert it into slope-intercept form, I want to have the y on my left side alone, with nothing else. So I'm going to have to do a few things. First, I'm going to subtract 3x from both sides. So then I'll get 4y is less than or equal to negative 3x plus 12. Then, to get y alone, I'm going to have to divide everything by 4. And I'm going to find that this is y is less than or equal to negative 3 over 4x plus 3. Because 12 divided by 4 is 3. All right, so now I have an inequality in slope-intercept form. So I can graph that. So I have my slope, which is negative 3/4, and I have my y-intercept, which is 3. So I can find those on my graph. My y-intercept is going to be right here. And because my slope is negative 3 over 4, I'm going to go down 3. So 1, 2, 3, and over 4, 2, 3, 4. I can do it the other way too. 1, 2, 3, and backwards 4. So this way. And then the more points I graph, the more accurate my graph is going to be. So this boundary here is going to be solid because I have that equal sign right there. And now I can find which way I'm going to shade by looking at this y is less than or equal to. So if my y-axis is less than or equal to this boundary line, that means everything less than this line is fair game. So I'm going to shade in all of this, everything below my line. All of those points make my inequality true. Let's graph this second inequality. This one is a little bit different. So you'll notice I have no y here. And you remember when we graphed equations like x equals 2, we would just find where x is 2 on the graph and draw a straight up and down vertical line. We're going to do the same here, but we're going to shade. So I found x equals 2, and now I'm going to see that x has to be less than or equal to 2. So anything on this x-axis that is less than this line is fair game. So I shade in everything left of that line. And now I can find that place where both of my shaded regions overlap, and that is where my solution set for my my system lies. So you'll see it's everything that's shaded both blue and red. So I stop when I hit that red line. So everything in this region right here, those points all make my system true. All right. Thanks for watching, and now you can try these at the bottom of your guided notes.